At the very heart of our planet, there's a mystery. A world hotter than the surface of the sun, under pressure so intense it's almost impossible to wrap your head around. So today, we're going to be detectives. We're going to follow the clues and try to crack the case of the Earth's core.
So right off the bat, here's the biggest question. How in the world do we know anything about a place that's 6,000 kilometers away, straight down? I mean, we can send probes to the far reaches of the solar system, but we've never, ever seen the center of our own planet with our own eyes.
You see diagrams like this, and it looks pretty complex, right? But for our investigation, it's pretty simple. We live on the crust. That's just a paper-thin skin, really. Below that, you've got the mantle. And then, way down deep, that's our target. The liquid outer core and the solid inner core. That's where we're headed.
Okay, so let's start our investigation by just facing the facts. Going there ourselves, it isn't just hard, it's physically impossible with any technology we have today. The center of the Earth is, for all intents and purposes, an unreachable world.
The numbers here are they're staggering. We're talking temperatures that can hit 7,000 degrees Celsius, hotter than the sun's surface. And the pressure? About 3.5 million times the pressure you're feeling right now. To put that into perspective, our deepest drill ever, the Kola borehole in Russia, only made it 12 kilometers down. 12 out of a 6,000-kilometer journey. We barely, and I mean barely, scratched the surface. So, if we can't drill there, how do we know anything at all? Well, imagine you're a detective listening for clues through a really thick wall. That's kind of what scientists do. They listen to echoes from deep inside the planet, using the Earth's own vibrations to piece together a picture of what's in there. And the biggest clues come from earthquakes. See, every earthquake sends out these vibrations, called seismic waves. And there are two main types you need to know about. First, you have P waves. Think of them like sound waves. They push and pull, and they can travel through pretty much anything. Solids, liquids, gases, you name it. But then you have S waves. These are different. They move side to side, kind of like a wave on a rope. And here's the crucial part. They can only travel through solids. They can't go through liquid. This one little difference, well, it's the master key that unlocked the whole mystery of the core. And this was the big aha moment. When scientists started mapping where these waves went after an earthquake, they saw something amazing. On the exact opposite side of the planet from the quake, there was this huge area, a shadow zone, where no S waves ever showed up. They just vanished. And there was only one possible explanation. They must have hit a giant layer of liquid that completely blocked them. This was the first real proof that Earth has a liquid outer core. But one clue is never enough in a good detective story, right? Seismic waves were a huge piece of the puzzle, but to really build a solid case, scientists needed to back it up with evidence from other places, looking to outer space and into some super high-tech labs. So two other key pieces of evidence really sealed the deal. First up, meteorites. These are basically leftover building blocks from when our solar system was forming, and a lot of them are packed with iron and nickel. Since Earth was made from that same cosmic recipe, it's a pretty strong hint that our super-dense core is also made of iron and nickel. Then you have these incredible lab experiments. Scientists use these things called diamond anvils to squeeze tiny samples with the same insane pressures you'd find in the inner core. And what they found is that even at thousands of degrees, that much pressure would force iron to become a solid. This lines up perfectly with the idea of a solid inner core sitting inside a liquid outer core. Case closed, or so they thought. For a long time, that was the textbook picture. A liquid outer core, a solid inner core. Simple enough. But just when we thought we had it all figured out, the story took a turn. It turns out the core isn't just some static ball of metal. It's a dynamic, changing, and frankly, weird place. Now, you might have seen some wild headlines recently, stuff like, the Earth's core has stopped spinning. Well, let's just clear the air on that one. As experts from Spain's National Research Council put it, the first thing to know is that the core has not stopped, not at all. The best way to think about it is this cars on a highway analogy. For a long time, the solid inner core was actually spinning a little bit faster than the rest of the planet. Now it seems to have slowed down to match the speed of the mantle and the crust that we're on. So from our perspective, it looks like it's paused. It's just like when a car in the next lane matches your speed. For a moment, it seems like it's standing still right next to you. But you're both still flying down the highway. The core is still spinning right along with us. And the plot just keeps thickening. It's not just the core spin that's changing. Now, scientists think its actual shape is changing too. They believe it's warping and deforming over time,
maybe because of the gravitational pull from the mantle above it or the churning liquid metal all around it. So we have a core that's changing its rotation and even changing its shape. But the latest chapter in this detective story, well, it reveals a secret that was hidden even deeper at the very, very center of it all.
By looking at how seismic waves don't just pass through the Earth once, but actually bounce back and forth across its entire diameter multiple times, scientists found a new clue. They found evidence of something that no one had ever suspected was there.
A distinct object, a solid metallic ball sitting right at the center of the inner core, with a radius of about 650 kilometers. You heard that right. Australian seismologists have basically found a fifth layer of the Earth, a solid innermost core. It seems to be made of the same iron and nickel, but the way its atoms are arranged, its crystal structure, might be different. This could mean it formed during a totally different phase of Earth's history. We've literally found a core within the core.
So, after all this, you might be asking, okay, that's cool, but why does any of it matter to me? Well, it matters a lot, because that churning liquid outer core, it's our planet's engine. All that motion creates a massive electrical current, which turns our core into a giant dynamo. And that dynamo generates Earth's magnetic field. This field is like an invisible shield extending way out into space, and it protects every living thing on this planet from a constant blast of deadly solar radiation. Without it, life as we know it simply couldn't exist.
And here's the best part. Here's how we know our detective work is paying off. On the top, you can see Earth's actual magnetic field as observed by satellites. And on the bottom, that's what our computer models predict the field should look like, based on everything we think we know about the core. I mean, just look at them. The patterns, the hotspots, the similarity is absolutely stunning. It's powerful proof that even though we can't see it, our clues are leading us to the truth. So, we've gone from a simple 4-layer model of Earth to this dynamic, shifting heart with a mysterious, secret sphere at its very center. Our picture of the core is always changing. Every new echo we hear from the deep adds another twist to the story, revealing more about this incredible engine that makes our world a home. The investigation is far from over, and you have to wonder, what will the next echo from the deep reveal?